November 2012, Paper 2. Question 1. Work out the value of x. Straight away in this question we can work out the size of this angle here, let's call it y, by doing 180 take away 105, which gives us 75 degrees. We know that the angles in a quadrilateral all add up to 360 degrees, so x is going to equal 360 minus 100 plus 50 plus 75, and this gives us a value of 135 degrees. Question 2. Here are John's marks in two tests. Test A, he scored 18 out of 25, Test B, 30 out of 40. Which test gives the higher percentage mark? You must show your working. So Test A, if we convert his raw mark into a percentage, that's 18 out of 25. Now the easiest way to convert this into a percentage would be to write this as a fraction with a denominator of 100, which means we need to multiply the numerator 18 by 4 as well. 18 multiplied by 4 is equal to 72, so this is 72%. Test B, 30 out of 40, well we can simplify this fraction to 3/4, which we should know is 75%, so it's clear that he scored a higher percentage mark in Test B. And if we want to make it perfectly clear, we can just say 75% is greater than 72%. Question 3. Solve this equation. So the first thing we're going to do is expand the brackets so that we get 6x plus 12 plus 8 equals 50. Simplifying the left-hand side gives us 6x plus 20 equals 50. Then we can subtract the 20 from both sides, which gives us 6x equals 30. Then dividing by 6 gives us x equals 5, which is our final answer. Question 4. Put each of these numbers into the correct box. So we have a two-way table that we need to complete with 5 blank spaces and 1 shaded space. So any number we fit into a box has got to satisfy 2 criteria. So, for example, the number that goes in this box here has got to be a cube number and a square number. If we look at the list above, 64 is the only number that will fit the bill. Here, we've got to have a cube number that's also an odd number. The only 2 cube numbers left in the list are 27 and 8, so we're going to need to use 27. Here, we fill in a number that's a cube and an even, so that leaves us with 8. These 2 boxes here, we have to have a prime number that's also odd, so that's got to be 11. A prime number that's also even, that leaves us with 2. So the table is complete. For part B, why is it never possible to put any number in the shaded box? Now, the shaded box, any number that would go into this would have to fit 2 criteria. It would have to be a prime number and a square number. Now, by definition, square numbers cannot be prime as they have at least 3 factors, 1, themselves, and their square root. The exception, I suppose, to this is 1, which only has 1 factor of itself, but 1 is defined as not being prime, so it's impossible to fit a number into this box. Question 5. Work out the value of a when x equals 6 and y equals -1. So we have to substitute the values of x and y into this formula to work out a. So a is equal to 4 multiplied by 6 plus 3 multiplied by -1 divided by 6 minus -1. So this is 24 minus 3 divided by 7, which works out to be 21 over 7, which is 3. Question 6. Circle the 2 equations that are equivalent to 2y equals 3x plus 4. Now, if we start with 2y equals 3x plus 4, if we subtract the 2y, we'll get 0 equals 3x minus 2y plus 4, which is the same as d, so that gives us one option. If we then divide both sides by 2, so we then get y equals 3 over 2x plus 2, and then subtract the 3 over 2x from both sides, we'll get y, take away 3 over 2x equals 2, which is B. So the answers are B and D. Question 7. The diagram shows a circle inside a square. We have to calculate the area of the circle. Now, the first thing to note is that the radius of the circle is equal to 4 centimetres. We then need to use the formula for the area of a circle, which is pi r squared, and then pi multiplied by 4 squared, or pi multiplied by 16. We can type this into our calculators, which gives us an answer of 50.2654 ... and if we then round that to a sensible value, we can give our answer as 50.3 centimetres squared to 3 significant figures. It's worth noting that an answer of 16 pi would also have been acceptable in this question because it doesn't specify a particular degree of accuracy to which we have to round our final answer. Question 8. Work out the area of the triangle. Give your answer to 1 decimal place. So we have a very simple triangle here. We need to remember that the area of a triangle is equal to a half multiplied by the base multiplied by the height, or base times height and then divide by 2. So on our calculators we need to do a half multiplied by 8.6 multiplied by 5.2, or multiply 8.6 by 5.2 and then divide by 2, whichever way you want to calculate it. The answer should come out to be 22.36, and ensuring that we give our answer to 1 decimal place, our final answer is 22.4 centimetres squared to 1 dp. Question 9. Show that the equation x cubed plus 8x equals 30 has a solution between x equals 2.2 and x equals 2.3. So what we're going to do is substitute in x equals 2.2 first of all into this equation. So x cubed plus 8x is then equal to, if we type this into our calculator, so we're going to do 2.2 cubed plus 8 multiplied by 2.2. This gives us a value of 28.248, which is slightly less than 30. If we then substitute in x equals 2.3, so we're now working out 2.3 cubed plus 8 times 2.3, this gives us a value of 30.567, which is slightly greater than 30, which would mean that the equation x cubed plus 8x equals 30 has to have a root that's between 2.2 and 2.3. Question 10, Part A. A drink is made from 1.5 litres of orange juice and 7.5 litres of lemonade. What fraction of the drink is orange juice? Give your answer in its simplest form. So the total volume of drink is equal to 1.5 plus 7.5, which comes to a total of 9 litres. The fraction of orange juice is 1.5 over 9, which, if we simplify that as a fraction, comes to 1/6. Now, if we double both the numerator and the denominator, we'll get 3 over 18, which we can then simplify to 1/6. Part B. A different drink is made from 2 litres of blackcurrant juice and 12 litres of water. How much more blackcurrant juice should be added so that 25% of the drink is blackcurrant juice? So let's say that X is the additional or the extra blackcurrant that we're going to add in. Now, the total amount of blackcurrant when we add this extra in is going to be x plus 2 litres. The total volume of liquid overall is going to be x plus 2 plus 12, or x plus 14. Now we want the total volume of the blackcurrant to be 25% of the overall liquid. So we want x plus 2 over x plus 14 to equal 1/4. So if we simplify this equation, we get 4 lots of x plus 2 equals x plus 14. This gives us 4x plus 8 equals x plus 14. 3x is equal to 6. X is equal to 2 litres. So we need to add in 2 additional litres of blackcurrant. Another way to think about this is that if we want 25% of the drink to be blackcurrant juice, then we want the 12 litres of water to represent 75% of the total, which means that 4 litres represents 25% of the total volume. Now, as we already have 2 litres of blackcurrant, we need 2 litres extra of blackcurrant to make up 4 litres in total. Question 11. Mark went fishing on 4 Saturdays, and the table shows the information about what he caught and how long it took him to catch the fish. Question 11 part A. Work out the mean number of fish caught per hour in week 1. So we're working out the mean number of fish caught per hour in week 1. So he caught 4 fish in 2.5 hours, so we need to do 4 divided by 2.5, which works out to be 1.6. 11 part B. Mark says, one of the fish I caught weighed 5 kilograms. In which week did this happen? Give a reason for your answer. Notice that this is a starred question, meaning we have to be careful about how we explain our answer. I'm going to add an extra row to the table, which gives us the total weight of the fish caught, which we can work out by multiplying the mean weight of the fish caught by the number of fish caught. So for the first week, 4 multiplied by 1.2 gives us a total weight of fish of 4.8 kilograms. Week 2, 1 fish weighing 2.3 kilograms. Week 3, 6 multiplied by 0.8 gives us a total weight of 4.8 kilograms. And in week 4, 3 multiplied by 1.9 gives us a total weight of fish of 5.7 kilograms. Now, in weeks 1, 2 and 3, the total weight of the fish comes to less than 5 kilograms. So it's only in week 4 where it's potentially possible to have caught a fish that weighed 5 kilograms. Question 12, Part A. Expand and simplify x plus 6 squared. Now the crucial thing to remember here is that this is a pair of double brackets, so we have to make sure we write x plus 6 multiplied by x plus 6 and then expand our double brackets carefully. So this gives us x squared plus 6x plus 6x plus 36, and we need to make sure we simplify this pair of middle terms, so our final answer is x squared plus 12x plus 36. 12 Part B. Expand and simplify this expression here. It's a starred question as well, so we must be careful to show every step of our working. So, expanding the brackets in turn, first of all, gives us 27wx minus 36wy minus 5wx minus 5wy. Collecting like terms gives us 22wx and minus 41wy, so our final answer is 22wx minus 41wy, which we can leave in that format. Question 13. Matt made this spinner. He spins the arrow 200 times. 13 Part A. How many times would you expect the arrow to stop on the number 5 if the spinner is fair? So, assuming the spinner is divided into 5 equal sections, it should land on the number 5 on 1/5 of the spins. So if we work out 200 divided by 5, which gives us an answer of 40, we would expect the arrow to stop on the number 5 40 times. 13 Part B. The table shows the number of times the arrow stops on each number. Do you think the spinner is fair? Give a reason for your answer. Now, if the spinner were actually fair, then we would expect it to land on each number around about 40 times. It lands on the number 2 about 40 times, but you can see it lands on the number 3 65 times, and it lands on the number 4 27 times, so not quite 40 in either case. So there's a possibility that the spinner is actually biased, and particularly biased towards the number 3. It is actually possible to argue that you've only actually spun the spinner 200 times, which isn't enough trials to test whether the spinner is actually fair, and in order to actually judge this properly you need to do about 1,000 spins to see whether or not the spinner is actually fair. Question 14. This pentagon has a vertical line of symmetry. The ratio of angles B to C to D is 6 to 3 to 4. Work out the size of angle B. Now, any pentagon can be divided into 3 triangles. So the total of the internal angles is equal to 3 multiplied by 180, which comes to 540 degrees. Now, by symmetry, angle A must equal angle C, and angle E must equal angle D. So, using this ratio, if angle B is 6x, angle C is 3x, angle A is 3x, angle E is 4x, and angle D is also 4x. So if we find the total of these angles, they must equal 540 added together. So 3x plus 6x plus 3x plus 4x plus 4x must equal 540, i.e. 20x must equal 540. So dividing by 20 gives us x equals 27 degrees. Therefore, angle B is equal to 6x, which is 6 multiplied by 27, which comes to a value of 162 degrees. Question 15. Work out the height h in this triangle. Now this is a right angle triangle. We've got a side length of 16 centimetres and we have an angle of 31 degrees, which means this is a trigonometry question. I'm going to start by labelling up my triangle. This side here is the opposite. This is the hypotenuse. And this side here is the adjacent. Now, I'm dealing with the adjacent, which I know, and I'm trying to find the opposite, which means that this is a tan question. Now, different people will do this question in slightly different ways. So, some people are quite happy to say tan 31 is equal to the opposite, which is h divided by 16. So, rearranging this equation, which will give us h equals 16 multiplied by tan 31. If we type that into our calculator, we get a value of 9.6137 ... which we can round to 9.61 centimetres to 3 significant figures. An alternative approach is to set up your TOA triangle. Now you're trying to find the opposite, so if you cover that up in your triangle, we know that the opposite is equal to tan times the adjacent, or tan of 31 multiplied by the value of the adjacent, which is 16, which comes to 9.6137, as we saw earlier. So our final answer, 9.61 centimetres to 3 significant figures. Question 16. The same students take 2 tests. The scores out of 50 are represented on the cumulative frequency graphs. Question 16, Part A. How many students took each test? Well, we can see that the highest value on the cumulative frequency scale is 80, which means that 80 students took each test. Question 16, Part B. Work out the median score for each test. So, we know that we need to find the 40th person. So for test A, if we go along to 40 on the cumulative frequency axis, and then along to the graph for A and then vertically down, we can see that the median for test A is equal to 20. If we do the same for test B, so track that line from 40 to the graph for B and then down to the x-axis, we get a median score of 35 for test B. Now, in 16 Part C, we're going to need to work out the interquartile range for test A, so I'm going to add some annotation to the graph now while we can see it on the screen in preparation for that. I'm going to work out the lower quartile for test A by marking on a line at 20, which gives us the lower quartile of 15, and the upper quartile I'm going to mark on a line at 60, which is 3/4 of 80. Go along to the graph for test A vertically down, and that gives me the upper quartile of 25. So 16 Part C. The interquartile range for test B is 13. Work out the interquartile range for test A. Now, we know that the interquartile range is equal to the upper quartile minus the lower quartile. So that's 25 take away 15, which gives us an interquartile range of 10. 16 Part D. Which test is more difficult? Give one reason to support your answer. Test A could be considered more difficult because the median score for test A was lower than the median score for test B. Question 17. These expressions represent three numbers. Work out the mean in terms of x. Give your answer in its simplest form. So to work out the mean, we need to make sure we add these three values together and then divide by 3. So that's equal to 6x plus 3 divided by 3, which if we simplify is 2x plus 1, making sure we divide both parts of 6x plus 3 by 3. Question 18. Solve this equation. Now the key thing to do here, first of all, is to multiply both sides by 3 so we no longer have to deal with a fraction on the left-hand side of the equation. Multiplying both sides by 3 gives us 18 plus 5x equals 3 brackets 10 minus x, or you may wish to multiply out the bracket on the right-hand side straight away. If we expand the bracket on the right-hand side, that gives us 30 take away 3x. Now, I'm going to add 3x to both sides as my next step, so that's 18 plus 8x equals 30. I'm then going to subtract 18, giving me 8x equals 12, and then to finish off I'm going to divide by 8, giving me x equals 12 over 8, which is equal to 1.5. Question 19. Work out the equation of the line shown. Now the general form of the equation of a line is y equals mx plus c, where m is the gradient and c is the y-intercept. Now we can see very clearly here that this line crosses the y-axis at 4, so its y-intercept is equal to 4. To calculate the gradient, we're going to draw in a right-angled triangle, like that. Please use a ruler to do this. Now the height of that right-angled triangle is 2 units, and the base of that right-angled triangle is 4 units, which means that the gradient of this line is the change in the y-axis 2 divided by the change in the x-axis 4, which gives us a half, or 0.5, as the gradient. So the equation of our straight line is y equals a half x plus 4. Question 20. The diagram shows a circle centre O, and we have to work out the value of the angle labelled A. Now, first of all, OB is a radius, so is OC, which means that triangle OBC is isosceles, and this angle here is also 42 degrees. We can then work out the size of the angle BOC at the centre by doing 180 minus 42 multiplied by 2. This gives us a value of 96 degrees, and then we know that the angle at the circumference is half of the angle at the centre when subtended from the same chord, so angle A is equal to 96 divided by 2, which is a value of 48 degrees. Question 21. XTY is a tangent to this circle. Write down the value of x. Now, we have a classic situation of a chord, a tangent, and from that chord we create this angle x here, which must be the same as the angle between the tangent and the chord. So angle x is 64 degrees, and the reason for this is the alternate segment theorem, which tells us that the angle between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. Part B. Work out the value of angle y. Now we can see that QRST is a cyclic quadrilateral, and we know that opposite angles in a cyclic quadrilateral add up to 180 degrees, so to work out y we need to do 180 subtract 83. So the answer is y equals 97 degrees. Question 22. The table shows the probabilities that I am on time or late for work each day. It also shows the amount of pay deducted for being late each day. So as you can see from the table, I could be on time up to 30 minutes late, or 30 minutes to 1 hour late. There are 3 probabilities associated with each of these options, and then the amounts deducted are shown in the line below. Work out the probability that I have exactly £16 deducted over 2 days. Now, as this is a question where multiple events are possible over the course of 2 stages, we need to draw something like a tree diagram to help us keep all the information in order. So, we've got 3 possibilities for day 1. I could be on time, I could be up to 30 mins late, and the third option is 30 minutes to an hour late. We'll just label that as an hour late for simplicity. Now the associated probabilities are 0.6, 0.3 and 0.1. We then have to look at day 2. So there are 3 branches that can stem to show what happens on day 2. Again, I could be on time, I could be 30 minutes late, or I could be an hour late. And the same probabilities occur on each of these branches. Now, I have to work out the probability that I have exactly £16 deducted over 2 days. Now that can happen in a couple of different ways. I could be 30 minutes late on both occasions, so that's this path here. I could be on time on the first day, but then an hour late, up to an hour late on the second day, which is that path. Or I could be up to an hour late on the first day and then on time on the second day. So there are 3 possible options. Now, this means I have to calculate 0.6 multiplied by 0.1 for this path, 0.3 multiplied by 0.3 for the probability of this path, and 0.1 multiplied by 0.6 for the probability of the third option. I then have to add together the results of these 3 calculations. So that's 0.06 plus 0.09 plus 0.06, which comes to a total probability of 0.21. Question 23. The diagram shows a sector of a circle. Work out the area of the sector. Give your answer to a suitable degree of accuracy. So the simplest way to do this is to work out the area of a circle, which is pi r squared, so pi times 8 squared, divide by 360, which would give you the area corresponding to 1 degree's worth, and then multiply it by 130 to give you the total area corresponding to 130 degrees worth. If you type this straight into your calculator, you may get a value of 208 over 9 pi, which if you convert that into a decimal is 72.6056 ... which we will round to 72.6 centimetres squared to 3 significant figures as our final answer. Question 24. In the diagram, angle A is obtuse. Work out the size of angle A. Now we can see that we have angle B and the side directly opposite it, but we don't have any information about the side directly opposite angle A. So what we're going to do is work out the size of angle C, because we do have the side that's opposite that, and we can then work out angle A from there. So using the sine rule, we know that sine of angle C divided by the side opposite it, 10, is equal to sine 35 divided by 8. So sine C is equal to 10 multiplied by sine 35 over 8, which, if we type into our calculators, gives us a value of 0.716 dot dot dot. Angle C then equals sine to the minus 1 of 0.716, etc., which is 45.804 dot dot dot. And we can then work out angle A by doing 180 minus 35 minus angle C. And this gives us an answer of 99.1950 dot dot dot. So angle A is 99.2 degrees to 1 decimal place. Question 25. N is a positive integer. Prove that n squared plus 3n plus 2 must be a multiple of 2. Now, there are a couple of different ways of doing this question. One way of doing this is to notice that n squared plus 3n plus 2 factorises. And quite often, if we factorise expressions, they can be more useful to us. So if we factorise this, we can write it in the form n plus 1, n plus 2. Now, if n is any positive integer, n plus 1 and n plus 2 must be consecutive numbers, i.e. n plus 1, n plus 2 must be consecutive. Now this means that either n is even and then n plus 2 is even, or if n is odd, then n plus 1 must be even. Either way, either one of n plus 1 or n plus 2 must be an even number, so when you multiply them together, you're multiplying together an even number and an odd number, which means that the overall product must be a multiple of 2. Question 26, part A. On the axes, make a sketch of y equals x cubed. So y equals x cubed looks like this. 26, part B. Make a sketch of y equals 1 over x. 1 over x looks like this. Question 27. Is this a right angle triangle? You must justify your answer. So first of all, I'm going to work out what these side lengths are. So 5.8 multiplied by 10 squared is 580 millimetres. 1.16 times 10 to the power 3 is 1,160 millimetres. And 580 root 5 is 1,296.91 dot 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 millimetres. Now, if this is a right angle triangle, then the two shorter sides, if we square them and add the squares together, should add up to the square of the third side. So, if we work out 580 squared plus 1,160 squared, that comes to a total of 1,682,000. If we then take 580 root 5 and square it, we get 1,682,000 682,000, which means that 5.8 times 10 squared all squared plus 1.16 times 10 cubed all squared is actually equal to 580 root 5 all squared, which means the three sides of this triangle satisfy Pythagoras' theorem, therefore it is a right angle triangle. Question 28. Solve the simultaneous equations. Notice that this is a starred question, which means there will be marks awarded for the quality of our written communication, i.e. how we show our working step by step. This is a pair of simultaneous equations where we have one linear equation and one quadratic equation, or one non-linear equation. So, as both equations are equal to y, we can set them equal to each other. So we have 2x squared plus 4 equals 10 take away x. Now we have here a quadratic equation. We need to ensure that the right hand side is set equal to 0. So I'm going to add x to both sides. 2x squared plus x plus 4 equals 10. I'm going to subtract 10 from both sides. So 2x squared plus x minus 6 equals 0. And I then need to factorise this equation. I can do that in multiple different ways. If you want to use the technique for doing this, we can say that we need to start off by multiplying 2 by minus 6, which gives us negative 12. We then need to find two values which multiply to give us the negative 12, and which also add to give us the 1 that's in front of the 1x over here. Now the only combination of numbers that will do that is 4 and negative 3. And what we can then do is we leave our 2x squared alone, we leave our minus 6 alone, but we split this middle term, which was 1x, into plus 4x take away 3x. Now we then factorise the first two terms here completely, so that's 2x x plus 2. We're going to need this x plus 2 again, but we need to make sure that we expands to give us minus 3x minus 6, so we need to ensure there's a minus 3 in front of it. This then gives us our full factorisation of 2x minus 3, x add 2, and of course this was an equation, so it is actually equal to 0. From here we get two mini equations. 2x minus 3 equals 0, so x equals 1.5, or x plus 2 equals 0, giving us x equals minus 2. So we can fill in our x values of 1.5 and minus 2, but we have to then calculate our y values corresponding to these using the formula y equals 10 take away x, which was our first equation up above in the question. So 10 take away minus 2 is 12, 10 take away 1.5 is 8.5.